Welcome to another GCBASIC demonstration. This is a demonstration of the first phase of development for the AVR Series 1 DA and DB microcontroller support. Let's have a look what that is. So, challenge here is getting GCBASIC to support the AVR Series 1 DA and DB with all the compatibility support that we've had in the past. So that means that when you do a DI, when you set the direction of a port, it sort of works. We need to make sure we have that same compatibility. So what we're going to be using, we're going to be compiling some code. I'm going to use GCASM and then AVR ASM just to show you how things work. And this is the first phase of development. So why am I doing this? Because these challenges is that there are changes to the direct pin configuration. It's very different. So we're going to have a look at that to start with to see what that means. So I'm going to take you over to GC code, and I'm going to talk through the keys I'm pressing, but we're not going to see the dialog boxes. Let's just look at this piece of code. Hash chip Mega 328P. It's an AVR chip. Set the port direction to the out. So DIR port B out, do a loop. Let's just compile that and look at the source code it generates. Well, I have just used GCASM to do that, and this is the report that it generates. We'll zoom out on that and we can have a quick look, lots of code. But the part I wanted you to look at is in here. And it's this part here that says so the direction port B out. And with the old style chips, you just used, you copied the value of 255 to set all the ports to out. You would set it into a variable called sysValueCopy, and then you would use a register to DDRB, and you would simply set it. It is as simple as that. Well, let me just reassure you, DDRB and on its associates across port A, B, C, D, etc. does not exist. Why? Because there's this lovely document for microchip, and it tells you the difference between all these different chips. So it says in here that there's a document here that says all the differences in the DX chips. And one of them down here is you have to change the way you address the port. So we'll have a look at that. And essentially what you have to do in assembler is load a few registers to make it all work. So you need to load a register called port ADIR. You then load that into the address register, the indirect register. You have to read in the current direction. You have to set it with an OR statement, a logical OR, and then write that back. So it's a multiple step operation, which is different. In the previous, it was as simple as setting 2 instructions. So, as with all things in GCBASIC, there's always a way of doing things. So let's look at changing the chip in here to a tiny, the one I'm testing on, 3217. 3217. If I compile that up, pressing function key F6, it compiles it. Let's have a look what happened in the assembler. In the assembler, in the same area, set the direction of port B to out. It's now put a little marker in here. That's a bit of debug for me for later on. I'll remove that. And it's now loading in the new registers of port B underscore DIR. I'm doing port B. In the documentation, it was port A. It doesn't really matter. And then it loads the high register into the indirect register for the Z. Then I'm doing an OR statement and then writing it back. What's really clever is we can see this working. So what I'm going to do, I'm going to open up the preferences, and I'm going to change the compiler over to AVR ASM. And then we can actually see this working. I'm going to recompile it by pressing function key F6. And at the bottom of the screen, we'll see that it's compiled. Here it is, look. It says down here it's used AVR ASM, down here, and it's compiled it. So let's have a look what it's done. Now, I've loaded up ATMEL Studio 7, and I've linked in my program, the one I have literally just generated. So let me zoom out for you so you can see the whole thing. This is the code I have just generated. Might not believe me. We'll have a look by zooming in. Here it is. It says dir port B out. Well, back in my source code, because I can, I'm going to change that to an A. I'm going to recompile it, go back into here, and after it's recompiled, it says, do you want to reload the files? Yes, I do. And it now says, in my source code here, dir port A out. And we can see this all working in because I can actually use the debugger in here to see it's all working. So what I'm going to do is put a breakpoint in there, insert a breakpoint. I'm going to run the debugger and break it, let it break. And on the right hand side on the screen here, I've got the ports. So if I click on port A, it's got a series of settings on it, and we're going to see those change as we progress. We can also see that some registers change. And so what I'll do is I'm going to run the debugger to my breakpoint, which is here. Run to cursor. So what we've got on the screen here, we've got the Z register, which is the one I need to be updating. And it's doing some work. I can press function key F11. And it says in here that the indirect address it's going to pull in is from 0124. And that is the correct address for DIR for this particular port. I'm going to copy that into Z. I'm going to OR it, and I'm going to write it back. And we can see that we've got read-write operations into the register. But this is very different code from what was there previously. It's almost the same as what's in the documentation I showed you a little while ago. And we can have a look, just compare the two. The assembly says LDI R30, and it says 0. Well, these are fixed values for port A DIR, so I don't want that. So I'm using the low command and the actual constant for port DIR. Then I'm loading the high of that register, and then copying a value into a temporary register, not R24, but it's just a temporary register. I'm doing the logical OR statement just as before, and then I'm actually using ST to store the results back into that register. We have the start of support. Continue. So we have the start of support for these particular chips, which is fantastic. So the goal here is to get support for AVR Series 1 DA and DB. Watch this space. I will be changing the compiler over the next few days.